Okay, now we're going to talk about the different types of IPv4 addresses. We've talked about how IPv4 addressing works with the subnet masks and all that. Now we need to talk about a couple specific different types because there are some, and it's important to know what they are. So today we're going to talk about a little bit about why there are private IP addresses in IPv4, what the private IP address ranges are, and then also some other special addresses in IPv4 that aren't necessarily the private IP addresses, but there's other ones that matter that are reserved for various purposes. And we're going to talk about what those are and explain what those mean. And IPv4 is the first version of the internet protocol that matters. There were other versions before it, obviously, version 1, version 2, version 3. Version 4 was the first one that was stable and used and actually put into play. Iterations of the protocol and specifications and design ideas and things like that had been around for a long time, but v4 was the first one that got used, and it was deployed on ARPANET in 1983. So it's been around, not as long as ARPANET's been around since it came around in the late 60s, but it's been around for a long, long time. And it has over 4 billion addresses. And in 1983, over 4 billion addresses for stuff on the network made a lot of sense. There were probably 1,000. I couldn't find numbers exactly on how many devices were connected to ARPANET in 1983, but it was definitely less than 1 million. And so over 1,000 million addresses for things on the network makes a lot of sense. Says, you know what, let's go with it. 4 billion addresses, we'll never run out. No big deal, no problem, let's roll. So they took those 4 billion addresses, chopped them up into a couple different groups. And those groups were divided by class, depending on how large the network was. So we know how IP addresses are divided up. There's the dotted decimal, etc. Well, the first 126 in that first dotted decimal byte were divided up. They were the class A addresses, and they were networks where the first byte represented the network ID. The last 3 bytes represented host IDs. So that's 3 bytes, 2 to the 24th power, which is roughly 16 million. So there were 16 million hosts. There were 126 different Class A networks. Great. Then we took 128 to 191 and made those Class B networks. So there were 2 bytes for network IDs and 2 bytes for the host ID, which meant that there were roughly 65,535 hosts possible on those networks. And then finally, the Class C were the last ones that were reserved for handing out to companies for use on their networks. And there were a lot more Class C networks because there were 3 bytes for the network ID, which means there's a lot more numbers there that you can divide up, with only 1 byte for the host ID up to 255-ish, we'll get to the details there, hosts on those networks. So this is how we divided things up. We had these networks with 16 million hosts, these networks with 65,000 hosts, these networks with 250 hosts-ish. And then there were a couple other ranges that were reserved for other things. So multicast is a technology that we'll talk about a little bit some other time. And experimental, reserved for future use. Maybe someday we'll use this for something, but we're not going to worry about it now. And then finally, 127. That entire block was reserved for loopback. Now, what does that mean, loopback? Well, this is a picture you might have seen somewhere. There's no place like 127.0.0.1. Loopback is a way to refer to yourself. It's a way that your machine can give itself an IP address to talk to itself, and only for your machine to talk to itself. Your machine cannot send to other things on 127.0.0.1. Your machine has an IP address for itself. That is 127.0.0.1. It's like me. I say me, and I am referring to me. And you say me, and you're referring to you, not me, even though we're saying the same word. That's what localhost is. Localhost is a way to refer to me if I'm a computer. So 127.0.0.1, aka localhost, 2 different words for the same thing. It's a way for your computer to be able to talk to itself. Your computer can send a message out to the network, and only within the network card itself, does that get any traffic. So this 127.0.0.1 traffic is never sent outside of your computer. It never goes on the network. It never sees a switch. It never sees a router because it's only meant for your computer. And it's very, very helpful. And it's nice that there's an entire range of IP addresses. It's nice that we have all of 127.0.0.0, which means you can have 127.0.0.1 or 127.1.1.1 or 127.25.0.1 or 127.25.25.25. All different addresses that you can use to refer to yourself, which means that you can run different things on different local IP addresses, using those different sockets that are bound to different addresses. So your machine has lots of different addresses that it can use to talk to itself for whatever it is that you need to do. But the problem, going back to the class-full networks and the Class A, Class B, Class C, the problems with the class-full networks are, first of all, there's not enough networks. That was fine in 1983 when there were 100 or 1,000 or even 10,000 different things connected to the network. Not so great now. We have a lot, the internet's a lot bigger than it was in 1983, it turns out. And so having that limited number of networks, it's just not enough. There weren't enough Class C networks to go around. So we needed to split that up more. And the Class A networks were way too big. Nobody needs one network with 16 million hosts. And with the class-full routing, there was not a way to take that 16 million host network and split it up into smaller networks. You couldn't do it. So you had networks that had tons and tons of computers on them, but nobody got to 16 million. Back when they started and when they started handing out those IP addresses, nobody ever thought there would even be a case that we'd run out of IP addresses. But now we are, and we're running out of IP addresses, and so we needed to split up the network. And so we came up with a solution of classless routing. Of course, when I say we, I mean me and the others who invented the internet. So classless routing is the type of routing that we've talked about. As we talk about IP addresses and we talk about the subnet mask and what that means, the only reason we have to think about subnet masks and where things are divided is because we have classless routing. Because in class-full routing, the subnet mask was defined by whatever the first digit of your IP address was. But now we have arbitrary subnet mask length. Your subnet mask can be any length at all, and you can get a subnet and divide that subnet into even smaller subnets if you want to. And so you specify that subnet mask, and that's where we get things like the slash notation. The classless interdomain routing notation, CIDR, remember classless routing, that's where that comes into play. And this really saved the internet. This is what made it possible for us to have millions or billions of devices on the networks and on the internet. Because before classless routing, we couldn't. We were limited and we were out of addresses because you can't just hand out 16 million addresses to one company. It's too many. And it meant other people couldn't use them. So we split it. We saved the internet with classless routing. That's the first time we saved the internet today. So within those ranges of classful routing, there were some addresses that were reserved for local use. And you've seen these addresses before. You've seen them on your local network that your router at home might hand out to you. You have seen them when you connect to public Wi-Fi. There's lots of places that you have seen these private addresses. And the private addresses are reserved for local use. They are reserved for within a network. They can't be sent out to the internet. And we'll talk about network address translation, which is the way that you can use a private address here and use a public address out there. But just know that a private address can't be out there on the internet. Google is never going to know what your address is on your local network. Network address translation makes that possible. Topic for another video. So the private address ranges are 10.0.0.0/8, 172.16.0.0/12, and 192.168/16. And you have seen this bottom one. I know that's what your local router uses because that's what they all use. But if you wanted to, and this was the first thing that I did when I learned about these private IP address ranges, I updated my router to use 10.0.0.0. Why? Because I thought it was cool. It made me feel cooler than having the 192.168 that everybody else has. The coolest is to use the 172.16 because nobody ever uses that. 10 is used a lot, 192.168 is used a lot. The 172.16, not so much. But these ranges, you'll notice /8, /12, /16, because of those slashes, there is a range of addresses, a range of networks that are a part of that. And for the 172.16.0.0/12, what that means is everything from 172.16.0.0 through 172.31.255.255 is a part of that network. So, or part of that subnet, part of this subnet. So every address that starts with 172.16 all the way up through 172.31 is part of that private IP address range. So you could use at home, you could say, I want to use 172.17, 172.18, 172.30.0.0 as my subnet. And that's part of why nobody uses this range, because it's not as easy to remember. Starts with 10, private IP address, easy to remember. Starts with 192.168, private IP address, easy to remember. 172.16 through 172.31, not quite as easy to remember. Takes a little bit more work, worth memorizing those so that you recognize those addresses. Again, 192.168.0.0/16 means that everything from 192.168.0.0 all the way through 192.168.255.255 is on that subnet. So you could have your home address be 192.168.25.0/24. We'll figure out how to work out those IP addresses later, but it means that everything that starts with 192.168 all the way from 0.0 to 255.255 is part of that private IP address range. 192.169, not a private IP address. 191.168, not a private IP address. But 192.168, everything there is. The nice thing about private IP addresses, reusable addresses. So you can have your address in your house be 192.168.1.10. And I can have my address at my house be 192.168.1.10. And that limits the number of IP addresses we use. Remember, we're running out of IP addresses. There's only 4 billion IPv4 addresses. There's more than 4 billion computing devices on the internet with phones, tablets, laptops, desktops, smart devices, smart doorbells, servers, enterprise computers, workstations, all the different devices that go on a network. That's way more than 4 billion. So we've needed to step it up and give reusable IP addresses with those private IP addresses. It also allows you to create a full internetwork locally that's completely separate from the public IP addresses that work on the internet. So everything that's not a private IP address that we've talked about is a public IP address, which means it can work on the public internet and be routed and do all the internet-y things. But private IP addresses, you can create a full internetwork locally. You could have one network in your house be 192.168.1.0 and another network in your house be 192.168.2.0. Have two different networks that are each independent of each other, maybe routed traffic between them, maybe not if you don't want to, using those private addresses without having to pull down a whole bunch of public IP addresses and keep those for yourself. So that's pretty handy. Provides a little bit of internal security, so you can have, I can have 20 devices inside my house, but as far as outside the network is concerned, I only need that one IP address. Nobody outside my house knows how many devices I have inside my house because they don't need to. And this saved the internet again. Again, we need more than 4 billion IP addresses, and private IP addresses has made that possible. So now we're going to talk about a couple other ranges of IP addresses that are important, or specific IP addresses that are important. And again, there's not really a connection between them. They're just important ranges of IP addresses that you need to be able to recognize and remember. So the first one is 169.254.0.0/16. You might have recognized this, you might have seen this before. If you've ever checked your IP address when you got on a network, thought you connected to the network, couldn't get on the internet, it said something about something not working or whatever, and you checked it and it said your IP address was 169.254. That is what's called an automatic private IP address, meaning your computer gives that IP address to itself. When you get online, when you get connected to, not when you get online, because online typically means you're connected to the internet, but when you're connected, when you get on a network, you try to get an IP address using DHCP. But if that doesn't work, you're going to give yourself a PIPA IP address, 169.254.0.0. And your computer's going to create this for itself to allow you to communicate. And this is self-configured. Your computer gives it to itself. Self-configured IP addresses are only useful within a local network, meaning they cannot even go through a router. Unlike we talked about private IP addresses, possible you can create a routed network within your local organization or whatever using those private IP addresses. You can't do that with these IPv4 addresses. It can only be used within a local network without ever passing through a router to do the routing thing to get to another network. Another special address, 255.255.255.255, which is remarkably hard to say. But this is what I call a universal broadcast address. When your computer doesn't know anything about the network it's connected to, but needs to send out a message to everything around it, it uses this address as the destination. So if you're in Wireshark and watching, you might see traffic where the destination is 255.255.255.255. This is essentially your computer shouting when it doesn't know where it is. If your computer has no idea about the network, it doesn't know what the network address is that it's connected to, it's just going to shout out to 255.255.255.255. Again, really, try it. Try saying it. I promise it's harder than you think it is. Another special address is 0.0.0.0, which refers to all IPv4 addresses. Typically, when you're using it, it's something like you're setting up a socket on a machine. And you can set up a socket on a machine and say, I want everything that comes to this machine, regardless of what IP address it's addressed to, whether it's from the local machine addressed to 127.0.0.1, or if it's from the outside addressed to the private IP address, or if you've got a public IP address, if it's from the outside coming to the public IP address, or if it's addressed to localhost, or if it's addressed to some other version of the name of this machine, I want that socket. And 0.0.0.0 is where you're going to see that. You'll see it when you're setting up a network connection. You'll see it when you're setting up a firewall. In AWS, for example, you will say 0.0.0.0, which refers to all IPv4 addresses that might come in. And again, this sets up for a socket for all IP addresses. If you configure a service to start up on 0.0.0.0:8000, for example, it's setting up that socket for all IP addresses on your machine, regardless of how many IP addresses that might be or how many different ways or names that traffic can use to get traffic to your machine. You have that option of setting 0.0.0.0 to refer to all of it. So before we wrap up, check yourself. What is 127.0.0.1? What are we talking about when we say 127.0.0.1 or localhost? Who uses it? What's it used for? When would you use it? And why? And where do private IP addresses get used? We've talked about private IP addresses, what the ranges are and all those things. Why are they used? What are they for? And finally, what were the issues with classful routing that led to the creation of classless interdomain routing and the CIDR protocols and possibilities that we've talked about?